Hello, geometry students. If you are seeing this, I am not here today. So we are going to do the best we can here. This is my first time making a screen recording with the iPad, but looking at the visual, looks like it'll work out just fine. So we're going to be looking at 5.6 and 5.2 today, just like we planned. This video, the limit on this recorder is 15 minutes. I'm going to do my best to keep it under that 15 minutes so that there's only one video and it's not too crazy long to expect you guys to be working with here. But I'm going to kind of move through it pretty quickly so that we can get under 15 minutes. Please, I strongly urge you to be copying this stuff into your notes. And then pause the video, rewind a little bit at a time, especially on examples. And I think this could be really useful. I think you'll get out of it what we need to have today be what it needs to look like. If all goes according to plan, I should be back tomorrow on Friday. For that short day, we can tie up any loose ends we might have. But this is going to set us up to get where we need to be by the end of the quarter. So we're looking at a few special types of triangles today. The first one we're going to see is called an isosceles triangle. So an isosceles triangle, a triangle with at least two sides congruent. And we're going to see some of those different scenarios as we go through the notes here today. The legs of an isosceles triangle are the two congruent sides. Okay, so the legs are the two congruent sides of the triangle. The vertex angle is the angle between the sides that are the legs. So the one angle that's potentially different, because then the base angles are the two angles formed by the base and the congruent sides. And those are actually going to be congruent to each other as well. So the legs and the base angles are going to end up being congruent. So we can see that here, okay? These legs congruent, these base angles congruent, and this top one is what we called that vertex angle up above. So this actually goes both ways with the theorems, is that if you know that two sides are congruent, so if you are given that or you end up proving that at some point, then you can go right ahead and say, all right, well, if those two sides are congruent, then I know for sure those two angles are congruent. And then vice versa. If I know, whether I'm given or I prove, if I know the angles are congruent, then I can go ahead and say, okay, then I know for sure that these two sides, these legs, are congruent. So it goes both ways. Whether you start with the angles or the sides, you can then say the other one is a set of congruents as well. So a lot of your problems are going to be pretty straightforward, where if you're given a triangle, something like this, you are given two sides congruent, and that vertex angle is given to you of 70 degrees. Well, like we talked about yesterday, all triangles have to add up to 180 degrees with their interior angles. So then I know, okay, the legs are congruent, so those two base angles must be congruent. Well, if I take away the 70 degrees that are already accounted for, there's just 110 degrees left. And if I know it's split between two congruent angles, then it has to split evenly. So I divide it by 2, and each of those angles are going to be 55 degrees. Okay, and then before we get into any further examples, the other special type of triangle we're looking at today is an equilateral triangle. So much like a square is a special type of rectangle, an equilateral triangle is a special type of isosceles. So this goes both ways as well. This is kind of your perfect triangle. If I know all three angles are congruent, so if I'm given or find out that all three angles are congruent, then I can go ahead and say, all right, well, now I know all three sides must be the exact same. Vice versa, if I know all three sides are congruent, whether I am given that or I find out, then I can go ahead and say, all right, well, now I know all three angles are congruent. And more so, we know then the only way for all three angles of a triangle to be congruent is if they're all 60 degrees. It's the only way that can happen. So specifically, they're congruent at 60 degrees each. Okay, so in a problem like this, all we can operate off of right away is that, all right, I know these two legs are congruent. And then you'll be given some angle like this one down at angle L. Well, in this case, I know both legs are congruent, so then I can immediately say both angles at the base are congruent. So if that angle L is 60, then angle K must be 60. So in this case, which is actually an even more specific case of an isosceles, is the fact that, okay, I have two 60-degree angles, so angle J must also be 60 degrees. And then if you were asked for side length LK, well, that's also going to be 12 because we are looking at an equilateral. In this example, when you're asked to find X and Y, so with the algebra piece involved here, this is kind of hard to see, but I am going to try to pick a bright enough color for us to pick out here. They're telling us right now that these two sides are congruent. So again, if I know two sides congruent, then their two base angles must be congruent. So that's these two. So measure of 60 has to be the same as that 6x plus 6. So for x, I'm going to be able to solve it this way. Just a couple steps, a simple algebraic equation for you to solve, and you will find your x of 9. So then to go ahead and find y, well, what we found out right now is, all right, if this angle at angle A is 60, angle C's got to be 60. So what does that tell us about angle B? It's got to be 60 as well. It's an equilateral triangle. So once I know that, and I have to go find my y now, well, now I know all three sides are congruent. So I can set those two things equal to each other. 4y minus 2 equals 2y plus 2. And again, it's going to be a fairly straightforward solution. You're going to get y equals 2. Okay, again, I'm going to be moving pretty quick. Pause this stuff if you need to. Now, when we're classifying, we're looking at either side lengths or angles to tell us what we're looking at here. So here I can see that I have two congruent sides. That's an isosceles. Next one, all three sides are congruent. That's an equilateral. Last one here, two congruent sides, isosceles. In case we're wondering, scalene is any other triangle. If you had like 7, 9, 11. I don't even know if those three side lengths are possible to make a triangle, but all three side lengths will be different in a scalene, meaning all three angles will be different as well. So when we're down here looking, and actually there's an example of one right there in B. So now when we're looking at angles, when they're all 60, they're all congruent. That's equilateral. Triangle B, three different side lengths. All right, so that's going to be the scalene example. Triangle C, we just have the two base angles congruent, so that is isosceles. And then triangle D, all three sides, equilateral. So down here, we're looking at a scenario where we are not given any angle measures and we're asked to find this angle. But what do we notice? All three sides are the same, which means this has to be an equilateral, which there's only one way to set all three angles congruent, which is that they're all 60 degrees. And then for part B, I have my two congruent legs. So the base angles are congruent. So when that one base angle is 40, the other's got to be 40 as well, because that is your isosceles. So in a situation like this, we're getting close on time, so I'm just going to set this equation up, not solve it. Again, I have my two congruent legs. So these two base angles that I've got expressions for have to be congruent, so their measures are equal. So you would start with 5x plus 17 equals 3x plus 35, and you would go ahead and solve for x. Now they are asking for the actual angle measure. So once you solve for x, that's going to go in those two expressions, and you'll find what that actual measure is. So moving on to 5.2, this is really straightforward, but we make mistakes with it a lot. Visually, it can be a little tricky to look at. Congruent polygons, all of the parts of one polygon are congruent to the corresponding parts of the other. Corresponding parts are the angles and sides that match up. Okay, so here they're marked correctly where, remember, we've kind of talked about this before, they might be positioned differently, but these different numbers of marks in an angle or a side are paired with the matching number of marks in the other angle or side. So the way that we would want to name this, okay, if I name the first one here triangle ABC, then I have to name the second one in the same order. So since I used A first, its matching angle of J has to come first. Since I used B second, its matching angle of K has to come second, and then L would come last. Likewise, if I name this in a different order, triangle, let's just say CAB, then I would have to go in that same order. So C matches up with L. I would have to say triangle L, and then A matches up with J, and then K has to be last. So it is necessary for us to name these in the correct order with their corresponding pieces. Something we'll get more used to, okay? So this one here, there's no marks, but we can kind of tell by those different sides and how everything kind of looks as if we could turn this one on the right to match up with the one on the left. So this X, the left-hand side the left-hand side on that short side, the X is going to match up with the B. So if I'm going to name the first one B, the second one would be X. Then we can go, if I go C, I have to go Y. So C on the top, Y on the bottom, and we'll keep going around in a circle. Not a circle, but clockwise. D would be next here, so Z would be next on the bottom, and then A, W. Okay, now this CPCTC, I just kind of blew by this quick. Corresponding parts of congruent triangles are congruent. Write that down. We're going to come back to that when we start doing proofs. That's going to be an important piece. Okay, so we're just about out of time. I didn't quite get to the end of this. I will finish it and post it to the notes or to the checklist, and we will be in touch hopefully on Friday. Have a good day.